Hi guys, welcome back. We shall talk about squint. It's a very important topic in ophthalmology. So squint has multiple names. Squint is also known as heterophoria, also known as strabismus. All are same, okay? Squint, heterophoria and strabismus, these all mean the same. Everybody is having squint. Everybody, you, me, I, everybody in this world is having squint. No one is having 100% parallel eye. No one is having 100% parallel eye. No one. If a person has like this, then we say it's orthophoria. Okay, but everybody is having squint. Heterophoria, strabismus, squint mean the same. Okay, so now let us see what is heterophoria and how it has been divided. Okay, it is divided into two sections. It's known as phoria and tropia. Okay, phoria means hidden squint. Why hidden? Due to balance, binocular balance. Let's say one eye is in the center and another eye is outward. The brain will give signal and tell the brain to make it centered. And so now it become in the center. This is known as binocular balance. Okay. Tropia means manifest squint. Okay, the squint that we can directly see, it's not hidden, it's not a hidden squint. All tropia will convert from phoria to tropia. Okay, when will phoria will become from phoria to tropia? When this binocular balance is either tired or not paying attention. When this binocular balance get tired, now this phoria will become tropia. And when you're not paying attention, let's say you're very crying, small babies, when they are crying, they're not taking their milk, or they are having temper tantrum, they are fighting, they're crying, they're rolling on the ground here and there. In that circumstances, this phoria turns into tropia for some time. Okay, because at that time the brain is not functioning on this binocular balance, it's not paying attention for binocular balance, and that time this phoria turns into tropia. Okay, now let us see how this tropia and phoria is divided. Okay, tropia and phoria, iso, exo, hypophoria, hyperphoria, isotropia, tropia. Okay, so it's been divided in this manner. Tropia and phoria is divided into iso, exo, hypo, hyper. Iso means inward, the eye is inward. Okay, towards the midline. Exo means eye is outside, that is away from the body. Hypo means looking downward, hyper means looking upward. Okay, so let us see what does iso means. Let's say this is normal pupil. Okay, this will be outward. No, this will be inward. This is known as iso. Exo means outward, iso means inward, hypo means downward, hyper means upward. Okay, that's how we will see, like in the eyes. Okay, remember, we should never say phoria left. In phoria we should never say left phoria or right phoria. We can never say, because why? Because of this binocular balance, you never know which eye is balancing which one. Okay, both may be having, and our body is balancing each other, so we can never say the person is having left esophoria or right esophoria. We will just say the person is having esophoria or exophoria or hypophoria, or like we cannot say left or right or hyper or hypo. Okay, we will directly say left. We cannot say in tropia we can say yes, left esotropia, right esotropia, right hypertropia, right hypertropia, but in phoria we cannot mention is it left or is it right. Okay, along with this we should understand about the gaze of our eye. Okay, if we just see the gaze of our eye, we have a primary gaze. Primary gaze is directly what you're seeing straight. Then you have secondary gazes. Secondary gazes are up, down, right, left. Okay, now you have tertiary gaze. We have up and right. Okay, we have down and right, we have down and left, we have 1, 2. Okay, we have up and left. So we have one primary gaze. Okay, 4 secondary gaze and 4 tertiary gaze. Okay, tertiary gaze are down and left, down and right, up and right, left and up and left. Secondary gaze are up, down, right, left. Primary gaze is the directly what you're saying, like this. Okay, now once we know this, now let us try to come back to tropia. This one, manifest. Remember, this phoria will convert to tropia either when you are tired, when you're not paying attention, or when this binocular vision gets tired. Okay, so test for tropia. Usually in many cases, you can't say many, but a lot of cases we don't need any test. We can directly see the person is having tropia because we can directly say the eye is not parallel. Okay, but in some cases we need to do a special case which is known as Herschberg's test. What is Herschberg's test? In Herschberg's test, this is, let's say this is your glabella. Okay, this is a glabella, the space between your two eyes, and we have the nose. We'll throw a light here and we can see the shine on the center of pupil. When we will see the shine on the center of pupil? When both the eyes are parallel. Okay, which are straight. Okay, which are straight. But in some circumstances, let's say okay, let us see, the shine here is in the center, but the shine is shifted this side. Okay, so now what does this mean? When you see this shine is iso, that means inward, inside. Okay, this is inside, but this eye is exo, so we will say this is exotropia. Again, this is exotropia, this is exotropia eye, but if we see for this shine, we will say iso shine. So whatever the shine is, make it opposite, because if the eye will go outward, then only the shine will move inward. If the shine is inward, it will go outward. Okay, so if the shine is exo, that means the eye is iso. If the shine is iso, the eye is exo. If the shine is hypo, the eye is hyper. If the shine is hyper, the eye is hypo. Exactly opposite. That's what you should remember. Along with this, you should remember, let's say this is the center of pupil here. Here is the center of pupil. So you will take a scale and you will measure the distance from the center of pupil to the shine. Okay, so 1 mm of difference will give you 7 degree of squint. Remember this, it's a formula type. And 1 degree of squint will give 2 prism diopter. Okay, so let us say example, okay, a person is having 3 mm difference. So what is the squint? 7 times 3 is 21 degree squint. Okay, this can also be written as 21 into 2, which will give you 42 prism diopter. Okay, so how we will write this answer? In total we'll write it 21 degree of squint, this one we can write iso or exo, whatever you want to write, whatever the eye is. In this case the eye was outward and the shine is inward, so this is exo, exotropia. Okay, we'll write it exotropia. Remember, in phoria we cannot mention it is left or right, okay, because of the binocular balance, and it is the distribution is hidden. Okay, it's actually hidden, so we cannot write that. So remember the formula here: 1 mm of difference will give you 7 degree of squint. 1 degree of squint will give you 2 prism diopters. And for tropia we will use the Herschberg test. In many cases we can directly see the eye is having some issue, both not parallel, but once you throw the light you can see the shine and compare the shine along with the pupil and measure the distance of distance between the atrial pupil, center of pupil, and the shine. Okay, and then measure it and then use this formula to find out. And everyone is having squint, and when this phoria becomes tired and it becomes tropia. This can be seen when you yourself are very tired or you are in emotional stress, you're not paying attention, then yes, this phoria will become tropia. And in some cases when this binocular balance gets tired. In later cases, everybody is having tropia will have phoria in some cases of their lifetime, past experience, and then this binocular balance will get tired eventually and it will become to tropia. That's all. Now we will shift to phoria. Okay, we'll now study what is phoria. Thank you.